Welcome, everybody, and good afternoon. My name is Samoan. I'm one of the regional sales directors. I have one of my colleagues and a very good friend, Ron Hussein, with me. He's one of our solutions architects. And welcome to our weekly webinar series. The topic of the webinar today is NCache architecture. We're going to be talking about what NCache is, how NCache can fit into your .NET or Java applications, depending on your preference, what the topologies are, what are some of the use cases, what type of performance numbers should you expect, and everything around it. We're going to be presenting. Ron is going to present the webinar. There's going to be a Q&A tab on the right or left hand of your screen where you can type your questions, and we will take those questions and try to answer to the best of our abilities. Anything that is not answered, please reach out to our support team, support@alachisoft.com, and we'll be more than happy to answer your questions. During the webinar, if you have questions or if you would like us to schedule a personalized demo or a webinar for you or your team, please let us know and we'll be more than happy to do that for you. Now, having said that, if you guys can confirm that you're able to hear us and see our video, I will go ahead and pass the control over to Ron so he can start the session. Okay, do we have confirmation? I can see and hear everything. Okay, very good. Ron, please go ahead and start the session.
Very good. Thanks, Sam. Hi, everyone. My name is Ron, and as Sam mentioned, I will be the main technical resource for this webinar. I'll present today's webinar, and topic that we've chosen today is NCache architecture. So in this particular webinar, I'll cover all the tech details about the architectural side of things for NCache, how NCache is architectured, what are the different kind of features that you could utilize, main topologies, and most importantly, some of the modern use cases that you can fit in NCache into your applications. So I think everything looks good. So let's quickly get started. First of all, I'll talk about the scalability problem. I'm pretty sure everybody knows what scalability is, but just for the sake of completeness, I would go over this concept one more time. Scalability is application performance at scale, right? So if your application works very well under low user load, let's say 5 to 10 users, and everything looks good, you have a backend database, and you make those requests, and your application performs pretty well. When you have less user load or associated requests from the users that are logged onto your application, and if you can maintain that same capacity, same ability under high user load as well, and by same capacity I mean the performance side of things, if you can have low latency under peak load, we would categorize that as a scalable application, and that ability would be called as scalability. So typically, applications are pretty scalable. You can take an example of ASP.NET web applications, or it could be backend server applications. You can have multiple servers host those applications, and that application tier can scale out linearly by adding more and more resources on the application side, right? So you can have 2 to 4 servers or more depending upon your load. So if you have less user load, you can start off with 2 or 3 servers, and if your load grows, you can gradually add more servers to help achieve the scalability. And how exactly scalability is achieved? By distributing load on those servers which are doing the same task, but they're doing it independently. So you can create a web farm, a web garden. So there are different techniques available to distribute load on multiple servers. So application tiers are in general scalable, where you can add more and more servers, and you can help ease on the application, and you can have linearly scalable model out of it, where you can put as much load as you need to, and your application is going to help serve all those requests by distributing the load. Typically, the data storage is the main bottleneck, because all of these applications, they may have to talk to backend database, right? So this could be a relational database, SQL Oracle server, and your application is talking to it for data access requirements. It could be a mainframe, it could be a web service, it could be a file system, it could be a NoSQL database. So typically your application is not the source of contention. It's very fast under your low user load, and it works pretty well under high user load as well. It's the data storage, which is usually a single point of failure to start off. That's one vulnerability because it's single source, and then it also tends to choke down under peak load. When you have less user load, your databases would work pretty well, They would help serve all the requests because they have the capacity of hardware to help serve all those requests. But when your application user load grows, database servers can hit capacity. If it's a single server, there would be a time where you may run out of disk resources, may run out of memory resources or CPU resources, and you don't have capacity to serve any more requests, and your requests would start to pile on, right? So as soon as those requests are queuing up, your end user performance is going to be impacted. So under high user load, latency also becomes high, and that's exactly what we're dealing with. That you should not have that problem. You should have high performance even under peak load with the help of a distributed caching system. And let me elaborate this with the help of a deployment diagram. So typically, if you don't have a distributed caching system, that is something that you can utilize to help relieve on the scalability problem side, right? So that can take care of this problem right away. So your application typically talks to a backend database, and that's a single source. It could be a NoSQL, SQL Server, or any other kind of data source. And you can introduce a caching tier in between your application and the database to help resolve this problem. And this caching tier, how exactly it resolves this problem? First of all, under less user load, your applications are working fine already, right? And this can improve performance even at that level. So it can improve the latency side of things by keeping everything in memory. So mode of storage with a distributed caching system like NCache is in memory, so it's already super fast in comparison to database. And on top of it, the main benefit where it helps relieve the scalability problem is having multiple servers as you have in your application tier. So you can create a cache cluster of multiple servers. It could be 2 to 3 NCache servers, and depending upon your load requirements, if your load is expected to grow or it grows as you are using it, you can add more servers on the fly. And by doing that, it takes care of all the performance and scalability challenges that you typically have with backend databases, such as a relational database which can hit capacity, or NoSQL, which demands that you re-architecture your application and replace existing relational databases. And it's also in most cases single point of data source. So that's how typically a distributed caching system like NCache is deployed, where you have multiple servers hosting the cache, and you have ability to add and remove those servers on the fly. And by adding those servers, you simply increase the capacity of how many requests you can handle. So you linearly improve request handling capacity by adding more and more servers. Here's a graph which represents some scalability numbers. With NCache, if you have 2 servers based on regular web server kind of configuration, average hardware, a box can give you 32,000 writes per second and 50,000 reads per second, right? So you can have with 2 servers, that's the kind of performance you can get out of, and scalability capacity out of a 2 node cache cluster. And like I said, you can add as many servers as you want to. On a horizontal axis, you can see 3, 4, 5, 6 NCache servers, and list goes on. You can add as many servers as you need to, and your transactional capacity increases as you add number of servers. So it's a linear improvement. By adding more servers, you get linear improvements in request handling capacity out of NCache, and that's something which makes it very scalable. So initially that we discussed that your application tier scales out nicely, but data storage is the main point of contention. Distributed caching system would take care of that. And this is how you would typically deploy it, where you have separate servers for your application and separate servers for caching, and your applications talk to it in a client server model. It could be containerized application as well, so you don't need to have separate servers. It could be a Docker image, it could be a container within any platform, and it would still be able to connect to it. And cache servers can help you improve performance, scalability, and reliability of your applications. So let's talk about some common use cases, and then we'll dive right into the architectural side of things. How NCache cache cluster is formulated, what are the main features around it, how is it architecture, and how you can utilize it in your applications for object and session caching use cases. First of all, I would talk about 3 main common use cases. These are technical use cases from standpoint of applications where exactly you can utilize it. So number 1 is app data caching use case. That's the most common one. Typically it helps you on the database related challenges, where database is a source of contention. It's a source of performance issues. it's not very scalable, and in some cases it's not very reliable as well. And that's an associated concept. When your database tends to choke down, it can give you end user performance degradation, and it can give you no response at all. In some cases your request can time out as well. So app data caching is the most common use case. Over, I think, 80% of our deployments have this use case where they utilize cache in between your application and the database, and some of the data or all of the data from the database that your applications need or most readily need is going to be cached in the distributed caching system offered by NCache. And all you need to do is use NCache .NET or .NET Core APIs to start getting data from the database and start adding that data into NCache. So you can add your domain objects, your collections, data sets, images, any sort of application related data can be cached using our app data caching API. And benefits that you get out of it: you improve performance in comparison to database. So it's super fast in comparison. It supports SQL search queries as well, so you can get the same kind of behavior out of distributed cache but faster response. And it's very scalable because you can have as many servers as you need to, so you don't need to worry about how many requests are being generated by end user which are currently active on your applications. You just worry about your application working and the architectural side of things of your application. As far as interaction with cache and the database is concerned, and increasing the capacity of request handling, that would be done on demand when you need to add more servers, and in response to that, it would help serve all the requests which are being generated. And it's very reliable as well. If any server goes down, there's no data loss, no application downtime. Second use case for distributed caching system offered by NCache is you can use it for web specific caching for ASP.NET and ASP.NET Core web applications. Now, most important use case here is the session state caching. If your web applications are using session state, you have ability to use our provider in ASP.NET and ASP.NET Core. So that's no code change option. You just plug in NCache as a provider, and NCache takes care of all your session data in the distributed cache. Now, this session data is something which is very important, right? So you wouldn't want to lose it. So benefits out of NCache session state provider is that it's very reliable in comparison to conventional options. In comparison to nproc, it's not going to require sticky session load balancing anymore. You can distribute your request evenly on all the caching servers because session data is not inside the application anymore. It's in NCache. It's very reliable. If any server goes down, a backup of that is made available automatically, so there's no data loss, no downtime. And on top of it, it's very scalable because you have multiple servers hosting that, so request handling capacity can be increased as your application load grows. In ASP.NET Core, we have two options here. You can use session state provider, or you can use iDistribute cache session management as well. NCache supports both of these options. View state is the second use case that you can use here. And by the way, for session state, we have a single site deployment as well as multi-site deployment as well. If you have geographically separated applications, one in Europe and one in US, you can use multi-site session support as well. And your users can bounce from one site to other and still be able to get session for maintenance use case, or for off scenarios where one user may expect itself to bounce to another site. That could be a rare scenario, but it's still possible.
Guys, we're at a 15-minute mark. I just wanted to make sure that there are no questions. Ron will just pause here for like literally 5 seconds.
Sure.
If I don't see any questions, you can go ahead and continue, please. Okay, I think everything looks good. Please continue.
Very good. Okay, so next use case, technical use case, is that you use it in view state caching. That's becoming obsolete, primarily because web forms need view state. The newer MVC platform does not need it. So for web forms, if you have a use case where you have ASP.NET web forms, you can utilize view state. And view state is something which goes back to the browser. It's encoded string. It's the state of all the controls, all the widgets, all the buttons that you have on a web form, and that view state is constructed on the server side. It's always needed on the server side, but it's always packaged. It's bundled with your response packets, so it's part of your response and it goes back to the browser, and that's where you can even see it. And once you post back on a page, that's where you need the state of those controls, and it becomes part of your response packet and comes back to the server. So it's just stored on the client end. It's never really used on the client end. It's always needed on the server side. And the issue with view state is that if you have a lot of controls, a lot of widgets, it becomes heavier in size. If you have bigger view state, your request and response packets are also going to become bigger. So it eats up your bandwidth utilization, right? So it uses bandwidth resources. It slows down performance because you're dealing with bigger payload, and it's a security concern as well because it's being exposed on the browser and it's never really needed on the browser end. So idea with view state caching is that you keep it on the server side and send a token back to the browser, and that token is going to be static in size, so your bandwidth costs are going to go down. Your performance is going to be improved because request and response packets are not going to be heavier anymore, and it's very secure as well because it's never exposed on the client end. So you can cache view state without any code changes for ASP.NET Web Forms using NCache view state provider. So that's the second use case that you can utilize here. Third important use case on the web side is the output caching, and on ASP.NET Core side it's the response caching, right? So if you have application which is static in nature, and by static I mean the content within a page is static. It could be entire page such as product catalogs for an e-commerce application, or it could be portions within a page which are static, and that information is something that you don't need to change, or that doesn't get changed between responses. So you can cache those page outputs or page responses for ASP.NET Core, and once the subsequent request asking for the same content comes onto your application, you can provide a cached copy from it using our output cache or response caching provider. And again, it's a no code change option. That's another use case that you can utilize and cache in.
Ron, there's a question, and the question is: there is also caching available in SQL Server. Is it similar type of caching, or is it different?
Okay, SQL Server caching, yes, it does give you response caching, which means any query that you have on the SQL Server side can be cached, and that response, if you issue exact same query, those records can be mapped. But again, that caching is on that same server, right? So that number one problem with that is that it can hit capacity, and in this case, it will hit capacity of the memory resources of this database server. Our NCache caching is completely different. It's pretty elaborate. It's a middle tier between your application and the SQL Server. There's no dependency on the database server at all. These are independent resources, and you can have multiple of such resources and formulate a cache cluster. So it's not just a single source. It's multiple. It's based on multiple servers which are working as a team and giving you linear improvement in capacity if you keep on adding more servers. And on top of it, there are many other features which are available on NCache side which are not available on SQL Server side. So yes, to answer this question, it's completely different. SQL Server caching is as similar as you would have in-prod caching within the application.
Thank you, Ron. I hope that answers the question.
Very good. All right. Next use case on the website is our SignalR. Use case. If you have application which is using SignalR for communication, you can utilize basically SignalR backplane. For web form, it's a requirement where you have to have a backplane in order for communication to be channeled to all the web servers and to the end users, right? So there's a bus, a message broker, which needs to be there, and NCache can be plugged in as a broker, a message bus for your SignalR applications, where your SignalR messages can be transmitted to NCache, and that will in turn transmit to all the web servers and then to all the end users for any events that you need to push. So for real-time applications, if you're using SignalR, you can use NCache as a backplane. And benefits of NCache backplane are that it's based on pub/sub mechanism, right? So it's loosely coupled as you would expect with SignalR. It's super fast. The capacity issues are not going to be there that you typically have with database, and it's very reliable as well. If any server goes down or maintenance use cases are needed, there's no single point of failure or downtime or data loss if you use NCache as a provider. Third important use case on the application side, the technical use cases that you need if you have application which needs to coordinate with one another. If there are multiple applications, or it could be microservices within one application, which is based on microservices approach, which are different, loosely coupled application services. And if they need to coordinate with one another, if they need to communicate some information, some data, some messages need to be passed on from one component to the other or from one application to the other, it's very difficult to implement that within the architecture. You have to have entire architectural implementation for communication, right? So NCache can be used as a pub sub messaging platform for your serverless applications. And for serverless, that's one use case, but it could be server based applications as well, which don't have any communication layer, and they want to rely on some kind of communication platform to relay messages. So it could be event driven, pub sub model based data sharing, where you have publishers and subscriber, and NCache is as a communication channel, and publisher and subscribers are applications which are connected to NCache. It could be data driven events where data gets changed, added, or updated in the cache. You can get notified via event messages, or it could be based on the data set, based on a criteria in the cache. For example, you map all the products with some certain category, right? So those products can be monitored for any change notifications, and NCache would send you those notifications if that data set gets changed. So our pub sub and runtime data sharing can give you app coordination use case. You can coordinate between applications. Data changes can be, chain notifications can be monitored, and data set change notifications can be monitored using this use case as well. So multiple applications can share their data. They can also communicate with one another using our communication channel. And that's our third use case. I hope it was pretty straightforward. Please let me know if there are any questions. We'll spend some more time towards the end, and we'll talk about some specific features around app data caching, ASP.NET and ASP.NET Core caching, and also on PubSub messaging as well. All right. Next, I'll focus on the architectural side of things, how NCache cache cluster is architectured. First segment here is self-healing dynamic cache cluster. NCache is based on a dynamic cache clustering protocol. First of all, it's our own implemented 100% proprietary protocol. We're not using any third-party or Windows clustering for that matter. It's a proprietary 100% peer-to-peer architectured cache clustering protocol. It's peer-to-peer architectured, so there's no single point of failure. You can add or remove any server on the fly, and you don't have to stop the cache or any of the clients which are connected to it. So dynamically, you can make changes to our running cache cluster. And when you do this, cluster heals itself automatically. It detects changes, and then it automatically heals itself and again becomes healthy, and there's no downtime or data loss on the client side. It's 100% uptime, a highly available cache scenario as far as your applications are concerned. There's a connection failover support which is built into the protocol, right? So there's a seamless support of connection failover, and it's done with the help of some cluster membership information events, and then cache topology information which is propagated to the clients, and then there is a membership map which is on the client side, which is a runtime which changes at runtime as well as you change anything on the server side. So if a server goes down, other servers would detect it and they would notify the clients at runtime, and as soon as clients are notified, they would make an intelligent decision, and then they would fail over their connections and start using the survivor nodes. So at any point in time, if a server goes down, a new server gets added, clients are fully aware of it, and then they start using the newly added server or the surviving server nodes if a server gets added or removed respectively automatically. So this is done automatically behind the scenes, so there's no single point of failure, no downtime on the client side. Everything is managed by NCache automatically. There are many ways you can create a cache. Next segment is caching topologies. These talk about different approaches you can create a cache. First topology, we have 4 different options, by the way. We have mirrored cache, we have replicated, and then we have partition and partition replica cache. And you can choose any one of these topologies, and based on that, a cluster would behave based on the set rules a topology comes with. So once you choose a topology, a cluster would behave based on those rules that topology has.
Ron, before you start this apology, I have a couple questions for you. First question is fairly simple. Are there any prerequisites for using NCache?
Yes, only prereq for NCache is .NET framework. If you have .NET framework available on the server side, and we need, I think, 4.6.2 for NCache. The current version of NCache 5.4 is released. I think it's targeting 4.6.2. So you need .NET framework. That's the only prereq for NCache.
Okay, and there's another question. How does it sync with the database connected?
All right, that's an elaborate question. Just to answer this, there are 5 different ways you can synchronize your cache with your databases. I'll just name those features because it's going to be a very elaborate discussion. I can share some documentation links towards the end of this webinar, or we can send an email as a response to this. But we have one option through SQL dependency feature where we map records in the database and database sends event notifications, and NCache allows you to remove or update those records automatically if they are changed in the database. Then we have polling based pipelining approach where if there are records changed in the database, you can deal with those records in bulk and you can apply those updates or remove those items from the cache in bulk. Then we have .NET CLR store procedure approach where you can make direct changes in the cache if there are changes in the database using NCache API directly in the database. And then we also have custom dependency approach as well, where we can have a custom logic implemented within NCache. It's a code which is a runnable code on NCache server side, and if there are any changes based on that code, we would know that there are changes in the data sources, and we'll execute that code and we'll be aware that database has been changed and we need to remove or reload those items in the cache. So like I said, there are 5 different features, and these, I'm planning a separate webinar on this where we would talk only about database synchronization and highlight all those approaches which are available within NCache. But I can share a documentation link for all of these features in an email in response to this question.
Okay, thank you. Please continue.
Very good. All right. Next, I would talk about caching topologies. As discussed, you choose a caching topology, and cache would behave based on the rules of that caching topology. So first topology that we have is called mirrored cache. We have 4 different set of topologies. So mirror is for smaller deployments, typically for 1 to 2 web server forms, where we have in mirrored cache we have 2 NCache servers, and that's the maximum that you can have. One server is going to be active, other server is automatically going to be passive server for that topology. And all your client applications, your instances or applications deployed on servers or within containers, those can connect to the active server only. So active server has all the data and it helps serve all your read and write requests. And by the way, we have 2 kinds of data in a typical scenario. We have reference data, which is more read intensive data, where we have a lot of reads than writes. And then we also have transactional data, which has either same number of reads and writes or more writes than reads, right? So for reference data and for transactional data, I would recommend that you choose a topology which suits your reference data requirements as well as your transactional data requirements. So this topology, we have read and writes performance equally fast because same server is having all the data. So reads and writes are directed to the same server. So reads and writes are super fast, one hop away from your client application. And this is an in-memory storage. So performance for this topology is not at all an issue. So it's going to give you very good performance for reads as well as for writes. Any data that gets added on or updated on server 1 is asynchronously backed up on server 2 as well. So there's an async replication going on between server 1 and server 2. So in case server 1 goes down, server 2, which is passive at the moment, no client is connected to it, it would promote itself automatically to an active state. So it would automatically become an active server. And these clients, as mentioned earlier, would fail over their connections, stop using this node because it's down, and they would automatically start using server 2. And this is completely seamless to your end users. If you bring server 1 down, server 2 automatically becomes activated and you get all the data from server 2. So there's no data loss, no application downtime. Async mirroring is used, which means clients add and update data from server 1 and return, and behind the scenes NCache updates the backup. So whatever data that you have on server 1, for example item number 1 to 6, these are going to be backed up on server 2 asynchronously, and these are pretty fast replication options. We have async mirroring, but it's within sub-millisecond. A dedicated thread is available which takes charge of all the items to be passed on to the passive server. This topology is good for reads, good for writes, very good for reliable data transactions. But only downside of this topology is that you only have one server which is active. You don't have ability to scale out. So if your if your requirements need to have more request handling capacities, then you have scalability issue. But if you're looking to just have caching, this is a good starting point for smaller configurations. Second topology that we have is called replicated cache. This is active replicated setup, which means we have entire copy of cache on each server. So data that you have on server 1, by design you would have the same data on server 2 as well, and we achieve this with the help of 2-way sync updates. So if you have two servers, server 1 is going to update all its changes to server 2, and server 2 would update all its changes to server 1. So at any point in time we have sync updates going on, which makes which essentially makes sure that we have same data across the board on all servers. And clients are distributed. We have auto connection load balancing implemented in this, where we have some clients are going to connect to server 1 and some clients are going to connect to server 2. So let's say if you have 8 instances of an application and you have 2 NCache servers, automatically half of them, 4 of those instances would connect to server 1 and 4 of those would connect to server 2. And this is done automatically. You can provide a preference, but based on the connection load on one server, NCache would shuffle those connections and ensure that we have equal load balancing between those servers. And connection balancing is something which NCache manages. You don't have to worry about these connections to be balanced. So some clients would connect to server 1 and some would connect to server 2. Clients which are connected to server 1, they would read from the same box. So reads are local, one hop away. So reference data applications can benefit from this with high performance for reads. But as far as transactional data is concerned, transaction is applied on all servers. So write operation is applied on server 1 and on server 2 in sync. Client waits until that is completed, and only then, once the operation is completed, client gets acknowledgement. So write operations are going to be applied on all servers. So writes are slightly slower in comparison, but for two servers, based on our experience, it works pretty fast for even for write intensive applications. This is very reliable as well. If server 1 ever goes down, there's no data loss, no application downtime, because these clients just need to fail over and start using server 2, which is survivor in nature. Now you can have as many servers as you need to, but we typically don't recommend going beyond 3 servers, because after 3 servers, one update has to be applied on server 1, on 2, and server 3 respectively, right? So in a sync manner, it has to be applied on all servers. So write's performance can go down. So we recommend at most 3 NCache servers, but it's again for smaller configurations and also for primarily for reference data scenario and also for reliable data transactions. So that completes our second topology. Next, I am going to talk about partition cache. Now this is our performance centric topology. Its architecture is completely different from mirrored and replicated. In partition cache, we have data partitioned automatically on all servers. So there would be a partition of data on server 1, a partition on server 2, and so on and so forth. You can have as many servers as you need to, but goal here is that each server would have its own dedicated data partition. So some data would go on server 1, some on 2, and some data on other servers which are part of the cache. Clients are connected to all the servers. Because data is distributed, it's available on all servers. Clients have to connect to all the servers. So they open each server, client application connects to all the server by design of this topology. And data is distributed with the help of distribution map and a distribution algorithm which works behind the scenes. So clients are the ones which are distributing data. So there's a distribution hash algorithm which works behind the scenes. It works based on hashing a key on a given server. So based on number of servers, that's an information that client has, and then it also has information about the hashing that it's using, and based on that it would hash a key on a given server. So clients are the ones which are distributing item number 1 and 2 on server 1 and item number 3 and 4 on server 2, and they are the ones who know that item 1 and 2 are on server 1 and item number 3 and 4 are on server 2. So reads and writes performance is super fast because clients are already aware where data exists. So read performance is super fast, writes performance is super fast, so you can use it for reference as well as for transactional data. You're pooling the memory resources of all the servers together, and each server contributes towards request handling capacity of its own set of data. So reads and writes capacity is going to improve as you add more number of servers. So with 2 servers, let's say you have 50,000 request handling capacity. With 4 servers, you would have 100,000 request handling capacity. So that's the kind of improvement you would get by adding more and more servers. And as you add more servers, you get more capacity out of the system as well. So you're pooling the memory resources, more storage out of the system. You're pooling the request handling capacity because more servers are going to contribute towards request handling capacity. So this makes it very scalable topology in comparison to the topologies. And already we've discussed that it's very good for reference as well as for transactional data. It works very well for smaller configurations, and it works even better if you have bigger configurations where you can add more servers. Only downside of this topology is it does not have any backup. So if you lose server 1, you lose that partition. So you need to have some kind of mechanism to fall back to the database and fetch that For example, you can use cache aside or read through approach, where you get data from the backend data source. So you should cache data which has a master copy in the backend data source. In case a server goes down, you don't have any data loss. So for performance centric scenarios and for smaller to bigger configuration, this is a very good topology to have, but you need to be aware that it does not have any backups, and that's the idea behind it, because it's more focused on the performance side of things. Now, enhancement to this is our fourth option, which is our most popular topology as well. It's called partition replica cache. Now, this is based exactly on the partition cache, but with enhancements of replica topologies as well, replica partitions as well. So one, in comparison of one partition, maintains two partitions. So each server in this partition has two partitions, an active data partition and a passive replica partition of another server. As you can see, server 1's active partition and its backup is on server 2. Similarly, we have server 2's active partition, its backup is on server 1. So each server is maintaining a backup of another server. And in case server 1 ever goes down, this backup is going to promote itself to active, and it would merge into the active partition of this server 2. So you get all the data, item number 1 and 2. If server 1 goes down, server 1's data, which are item number 1 and 2, are going to be made available from server 2, and this is completely seamless to end users. If server 1 goes down, your clients are going to fall back to server 2, and they would get all the data from server 2. There would be no data loss, no application downtime. And this is same topology with 3 server setup, and this is a comparison between partition and partition replica, where you have partitions and then we have replicas as well. And by the way, we have sync and async replica option here. In sync, client updates the active and backup, and only then operation is completed. In async, client updates the active, returns, and behind the scenes NCache updates the backup. So there's more performance in async and more reliability in sync. This is the same topology, partition replica, with 2 and 3 server scenario. In 3 server scenario, we have active partition of server 1, where clients are connected, and backup on server 2. Again, server 2 is active partition where clients are connected and backup on 3, and server 3 is active partition where clients are connected and backup on 1. So each server has a backup available within the cache cluster on another server. Now, if server 1 ever goes down in this setup, server 1's backup is on server 2. So server 2's backup is going to be, this partition is going to be activated right away. So there's no data loss, no downtime. And this backup merged into the active partitions of server 2 and server 3, and cluster heals itself automatically and again reconstructs into a 2-node healthy setup, where server 2's backup is on 3 and server 3's backup is fully backed up on server 2 is available, and cluster heals itself and again formulates a 2-node healthy cache cluster. And everything behind the scenes without impacting the performance or end user experience, it's done automatically by NCache protocol. Please let me know if there are any questions. This completes our 4 caching topologies that we have within NCache that you can choose from.
Okay, Ron, we do have a question. It's rather a long one. Can you please provide a few steps of setting up NCache server, as like we are implementing the NCache layer in some cloud services, or otherwise as architecture is clear but setting up is not. So I guess
All right,
they're looking for some steps to configure NCache.
that's something that I have planned within the demo. I think I can talk about this topology next, and then I'm going to go ahead and show you the demo of the product. And as part of that, I would also talk about how to set this up in the cloud environment as well. What are the best steps needed around that? So I think I can take this question once we move on to our hands-on portion.
Okay, I have one more question for you. Is serialization tag mandatory for data that is to be added in the cache?
That's a very good question. Yes, since cache is an out-of-process distributed caching system, it's in memory, but it's outside the application process. So for process-to-process communication, you need to have serialization, and serializable tag or any kind of serialization is a must when you plan on caching data in a product like NCache. So yes, that's a mandatory step.
Okay. Yeah, we're good. Please continue.
Very good. Next topology is client cache. It's a local near cache. It allows you to cache data on the application side, right? And it works in a function of L1 L2 cache, where we have a local subset cache data inside the application process or on the application box, and it's in sync with the server cache. Think of it as a L1 L2 cache in the hardware, where we keep data closer to the application in a cache which is nearby. So local near cache of NCache is a no code change option. It's a subset of the data from the server cache, and it's in sync with the server cache. So whatever data that you have in the client cache is always going to be in sync with the server cache, and synchronization is managed by NCache. Idea here is that you keep data closer to the application, and if you find data in the client cache, you don't have to go to the server cache. This cache is already saving expensive trips to the database, whereas client cache is even saving trips across the network to your clustered cache. And any changes that you make in the client cache or in the server cache are going to be propagated. For example, you change something in the client cache, that change is first going to be accepted in the server cache, and that in turn would be accepted in the client cache, and only then you would be able to complete that change. So it's primarily recommended for reference data scenario where we have more reads than writes, because if it's more reads, you would be able to keep reading data from the client cache and get performance gains. And if you have write intensive application, in that case client cache would negatively impact performance, because it needs to sync that update operation across the board. So for read intensive data, it's a performance centric feature where you can improve performance, and you can always keep it in proc, which means you can keep inside the application process, and at that time you don't get the serialization or inter-process communication overhead as well. You still need to serialize your objects, because your data exists in the server cache to start off, but client cache takes care of serialization and inter-process communication overheads. Last topology in this segment, and then I'll show you the setup, is the WAN replication. We have active passive setup, where you can have cache data from one data center transferred to another data center, but other data center is passive in nature. So it's a one-way active passive setup, and bridge is the feature where you can utilize. It's a queue, which is an active passive backed up queue. So we have an active copy of it, and then we have a passive copy of that queue as well. Currently active queue is going to be utilized, which is going to transfer data to the other side, but if active server goes down, the passive server can act as a active automatically, and it can take charge of all the subsequent operations. So cache from one side can transfer data through bridge to the other side, and this is done asynchronously, which means performance is not going to be impacted on this side of the clients. Clients only add data to the cache, and then cache behind the scenes transfer it to the other side cache across the WAN. And we can also have active where we have both caches activated on either on each side of the region, and they are connected to the bridge. Bridge is on one of the regions, primarily on your high traffic site, and then with async replication, data from site 1 is going to be transferred to site 2, and data from site 2 is going to be transferred to site 1. Default conflict resolution: if there are two updates for the same key come simultaneously, last update wins. So whichever was the latest update, that is going to be applied on both sides, and you can also have your custom config resolution implemented if that's a requirement. I think bridge is part of the same product, so you can utilize it for DR use cases, for east to west migration, for maintenance use cases. So list goes on for this feature as well. I'm going to show you the actual product in action. For that, I can use our demo environment. We have NCache server. So typically for cloud, NCache deployment is based on VMs, and that's consistent across the board. You can have Windows environment or you can have Linux servers, but NCache server side has to be on VMs. So you need .NET framework as a prereq, or .NET Core as a prereq for .NET Core deployments. And on the client end, you can either have a box, which is a Windows or Linux, or it could be containers. It could be cloud service, and you can use our NuGet packages, so you don't need any installation on the client side. So let's get started on the server side, and then we'll go back to the client side resources. So first of all, you need to create a named cache, and I can use this management tool or PowerShell tools if needed. And we're also we've released 5.0 version of NCache, which comes with web-based management tools, so that's something which is going to be slightly different. I'm going to name this demo cache, keep everything simple. We discussed 4 caching topologies, so you can choose any of these topologies. Partition replica cache is the one I'm going to go ahead with. Async replication option because it's faster. And I'm going to keep demo 1 is my first server where NCache server is installed. So you need a VM as a must, or it could be a Docker container as well. So NCache server side can be on VM, it could be on a physical box, or it could be a Docker or any other container which supports .NET Core or .NET Core framework. and we have demo 1 and demo 2 installed on it. NCache is installed. TCP port is the main mode of communication. NCache cluster is based on TCP IP based communication, so we need a port for server to server communication. So you need to ensure that there's no firewall between your server images or server deployments. And then we specify the size of the cache cluster, keep everything default. It's per server, so each server has 1 gig of space available, and then we have partition replica, so 1 gig on server 1 and 1 gig on the backup is needed. For the backup is needed as well. And if your cache becomes full, you have two options. You can either evict, you can reject new updates and use cache as a readable source only. No more data can be added, and you get an error that cache is full. Or you can turn on evictions, which are turned on by default, where you can remove some non-important item, readily used items, such as based on these algorithms, based on the priority of items, based on their usage. Least frequently or least recently used items can be removed to make room for the new items. But I would personally recommend that you keep a bigger cache size so cache never becomes full at any point in time. I'll keep everything default and choose finish, and that's it. That my cache has been configured. And on the client side, I have two options. I can either connect from an installation of NCache. For example, on my box, if I have an installation like here, I have NCache installed here, and if I come back here, I've added my box as a client. So I would see client side configurations inside NCache installation directory. So that's option number one on the client side. But that's not very cloud friendly, right? In the cloud, you may not have an application or a VM for it. But for applications which are deployed on VMs or on physical boxes, I would personally recommend that you install NCache client, and then you would have all the configurations in NCache installation directory. But in most other cases where you don't have a VM, in case of cloud services, you can use our NuGet packages. So you don't need any installation. You can just use our NuGet packages. If you go to the NuGet repository, if you look at this, alachisoft.ncache.sdk is installed inside this sample application, and if I go inside dependencies, I can show you this NuGet package right here, and it brings all the client-side resources inside the application as well, including the client.ncconf file as well. So that file can be even made part of the application. Once you include this NuGet package, it brings in all the client-side resources part of your application, and that's where you can you get started and connect to a cache which is configured. I hope this answers some of your questions, but if there are more questions around setting up NCache in cloud, please send us an email and we can give you specific steps. But just to highlight that there are two options on the client side. You can either go with installation or you can go with NuGet packages, and both options are supported. Alright, once we've done this, I'm going to show you, you need to start this cache. Cache has been configured on two servers which are going to be VMs as a must, and clients could be VMs or could be application instances using NuGet packages. Next thing is that you start and test this cache cluster. So I'm going to start this cache cluster, and I'm going to right click into statistics. This is going to open performance counters, and I'm also going to show you monitoring tools which come installed with NCache. For example, we have a server dashboard, and this is going to give you pre-configured dashboards, and no client is connected at this point. I'm going to go ahead and simulate some stress by using a PowerShell tool called test stress tool, and give it the name demo cache. So it's going to simulate some dummy activity on my cache by connecting to this cache. And notice I only specified the name of the cache, but you can also specify the IP using init params or using the configs which are part of your application. And it's generating about 1,000 requests per second on this server, and you can see server 1 and server 2 both are handling about 1,000 requests per second each. This is 1 kilobyte average object size. I'm going to go ahead and run another instance of this to show you how it scales.
Ron, I just want to make a comment here. We have about 10 minutes left, so kindly pace yourself accordingly.
Sure, thanks. Very good. Alright, so we have two instances running, and we have now 2,000 requests per second. So it almost doubled the request handling capacity by by distributing the load on two servers, and you can see this graph right here. So I can keep doing this until I hit capacity on CPU, on network, on memory side of things, and that's something that you can closely monitor, but that's a long way to go. If you have, let's say, 50,000 requests per second per server, I think that's when you may start seeing hardware capacity issues, and at that point in time you can add more servers and relieve the capacity issues. So you can scale out at a linear level. By adding more servers, you get more capacity out of the system. uh, this can be done on Linux environment as well. If I quickly show you the Linux servers, we have two boxes right here. We have 107 and 108. I'm logged on to one of the clients, so I can load this cache. Either I can start this cache from here. Let's do this. For example, start cache on 117. Let me just copy this command right here, and the cache that I'm looking at is, let's start my replicated cache. Let me name it first, my replicated cache. Right, so it's going to start my replicated cache on 117, and then I'm going to use add node. I'm going to add a node to this cache. Let me just edit my command in the notepad because that's convenient. Alright, I'm copying a command which says add node, cache name is my replicated cache, existing server is 117 where this cache is already created and started, and then 118 is going to be the new server. Where there you go. Now if I run a start cache command on 118, it is going to start it on 118 as well. So you can set this on Linux server provided that you have .NET Core installation, and after that it's pretty straightforward. For example, next thing that I can do is I can get a list of this server's caches, and I'm expecting my replicated cache to be available. 117 and 118 are two servers which are part of this cache cluster, and I can now run stressor tool from this as well. Our current monitoring tool allows you to monitor Linux caches as well from a Windows box, and our web-based monitoring is going to help you monitor Windows as well as Linux boxes through a web portal as well. So for example, 20.200.117 was the server, so I can even get a Linux server cache added in my Windows box. For example, 117, my replicated cache was the one, and we have two boxes right here. I think that gives you a pretty decent idea about management and monitoring details. You can have Windows boxes as well as Linux boxes, and from cloud standpoint, you can bundle your application with NCache resources using NuGet packages. But if you have a VM where your application is hosted, in that case, go with the client installation on the end box. A few things that I would like to highlight. This is our API. We have basic operation sample which you can utilize. If you go inside the basic operation.cs, this is how you connect to the cache. For example, let's go inside this right here. So first of all, you need to connect to the cache, and for that you can call cache.initialize cache, right? All you need to do is connect to the cache by initializing the cache, and once you've done that, you call cache.add to add items, cache.update, this is cache.get to get items from the cache, cache.update to update the items, or insert, cache.delete to delete the items, right? So this is pretty intuitive, straightforward API. And we have time-based explorations. We allow you to have synchronization with database. Again, we have SQL dependency, DB dependency, SQL and Oracle CLR store procedures. We also have Oracle dependency here as well. File-based dependency is available, custom dependency is available. So many ways to synchronize your cache with different data sources. And like I said, I'm planning a separate webinar on this topic. Handling relational data sources, databases, data with relational data inside the cache. You can have key-based dependency mapping relationships. One-to-one, one-to-many relationships can be mapped using this feature right here. SQL searches are supported. Link search is supported with NCache. You can search items based on a criteria. For example, from the cache, you can say select products where product.price is greater than 10 and product.price is less than 100. And NCache would execute that request on the in-memory storage. From the cache, it would fetch you all the results which are matching the criteria. Cache fetches can be done through key with individual gets, with bulk gets, and it can also be done through SQL searches. It can also be done through groups and tags APIs. So you can group items in the cache, assign different items with a group. assign them with different different item can be assigned with a tag, and then you can say get by group data or get by tags, and NCache would fetch you a collection with the matching tag out of NCache. Data access layer providers can be made part of NCache. Read through and write through handlers are supported. That's another way to interact with data sources, where you fetch something from the cache, and if you don't find it, instead of your application going to the database, read through handler can be invoked and it would get it from the cache, from the database automatically. And write through is for updating the cache and the database using a write through, which is your code but registered with NCache and called by NCache at runtime. Cache loader is a pre-population of cache, so you can pre-populate the cache at runtime, at startup, so that you have some data loaded in the cache already. And then we have some features on the ASP.NET Core side. I talked about these at startup, where you have session state caching, multi-site sessions are supported, ASP.NET and ASP.NET Core use cases are handled, response caching for ASP.NET Core, output caching for ASP.NET, ASP.NET Web Forms view state caching is also available as part of this. And then we have messaging platform, where we have item level events, cache level events, and then we have also custom events and pub sub messaging platform out of NCache. We have a pub sub feature implemented with NCache, where multiple applications can act as a pub sub to the cache. And Sam, just right in time, this brings us to the end of our presentation, so I would hand it over to you. So
Okay,
please
perfect.
take it up from here.
Thank you very much, Ron. At this point, we have a couple of minutes left. I would ask if there are any questions. We'll be more than happy to answer. We'll just wait and see. Okay, so there's a question. Is there a trial version of the product available?
Yes, there is. You can get a fully working 60-day trial. It's fully featured, and you can get started with it. And then down the line, you can also extend it as well.
Okay. You know what? I don't think we have any more questions. So we will wrap this session. Guys, if you have any questions that we didn't answer or was not answered the way you wanted it to, you are more than welcome to reach out to our support team at support@alachisoft.com. If you would like us to schedule a session, you can again contact either support or sales@alachisoft.com, and we'll be more than happy to schedule a session for you. Actually, there's a question. Can you share the entities between different applications in same cache region? Is it necessary to pick by the name of application?
Um, I think by cache region, prefix and not the prefix. All right. Can you share entities between different applications in same cache region? Yes, you could have same cache, which could have entities from different application, and still, because these are serialized differently for different applications. So a customer from one application is different from customer from another application. So if there's a question, if you have same entities from different applications but same prefix, same name, so yes, you can still cache them and they would be differentiated as well. Please confirm if my understanding on this question is correct. Otherwise, send us an email and we can help answer that question for you. So same cache region can have entities which are same named but from different applications. So it's going to serialize it differently, and with the cache key which is kept separate, so it would treat it as a separate entity.
Okay, perfect. So, Ron, with that, we're at the hour mark. I would like to thank you, everybody, for joining the session today. Like I mentioned earlier, if you have any questions, please reach out to us and we'll be more than happy to help out. Thank you very much for presenting, Ron, and we'll see you guys next time. Thank you.
Thank you guys. Thank you, Sam.